We'll discuss in this video lecture two more problems. Already we have finished 4.1. This is the fifth one, which is show that x is equal to 0 is ordinary point and x is equal to plus and minus 1 are regular singular point of the differential equation 1 minus x square d2y by dx square minus 2x dy by dx plus L into L plus 1 y is equal to 0, where L is basically a constant. Okay, so this already we are used to it, so this should not take some time, a few minutes only to solve this. So first we will arrange the equation. So we can say d2y by dx square minus 2x divided by 1 minus x square, fine, 1 minus x square dy by dx, correct, plus L into L plus 1 divided by 1 minus x square into y is equal to 0. So now we are in the proper form as far as d2y by dx square plus px, p of x divided by dx plus q of xy is equal to 0, correct. So how much is my px? Px is minus 2x upon 1 minus x square, and how much is q of x? It is L into L plus 1 divided by 1 minus x square. First job is to show x is equal to 0 is ordinary point. So how will we say? At x is equal to 0, okay, limit x tends to 0 of px is equal to limit x tends to 0 of minus 2x upon 1 minus x square will be, this is 2 into 0 upon 1 minus 0 square, fine, it will be 0 obviously, which is finite. Same way I'll do for the q of x also. So q of x will be limit x tends to 0 of L into L plus 1 divided by 1 minus x square, okay, this is 1 minus 0 square, correct. So this will give me L into L plus 1, because we said L, this is obviously a constant, so again this has come finite, okay. So this simply implies that px and qx remains finite at x is equal to 0, therefore x is equal to 0 is an ordinary point of the given differential equation, okay. So there is no doubt as far as proving that is concerned. Now next job is very, very important. We need to check x is equal to plus 1 and minus 1 both, okay. So first we'll go with the px value. So we need to check. So here I'll say x is equal to 0 is ordinary point. Now we'll say at x is equal to plus minus 1. Now first we have to check, why do you have to say regular singular, okay. So for that, what will I do? I'll say limit x tends to plus or minus 1, p of x is equal to limit x tends to plus or minus 1. How much is p of x? Minus 2x upon 1 minus x square. Done. So if x is, suppose I say minus 2 into plus 1 divided by 1 minus 1 square. First I put x is equal to 1. How much this will be? Minus 2. This is 1 minus 1 will be 0. So which is infinity. Okay. Even though I take minus 1, what will happen? Minus 2 into minus 1 divided by 1 of minus 1 square. Okay. So this is also 2 by 0 will be infinity. Done. This is infinite. Same way we will get for qx also. Okay. Means what? Limit x tends to plus or minus 1, q of x will be x tends to plus or minus 1 L into L plus 1 divided by 1 minus x square plus 1 or minus 1 will be, denominator will be 0, so this will be infinite. So as both these terms turned out to be infinite, therefore we can say confidently that yes, x is equal to plus or minus 1 is a singular point. This is not an ordinary point, but this is a singular point. So once it is defined, then what is our job? We have to check separately x is equal to 1 and then x is equal to minus 1. So how will we proceed towards that? I'll first check x is equal to plus 1. How we'll start? We'll start limit x tends to 1, x minus x0 p of x is equal to limit x tends to 0, x minus x0 into p of x. How much is p of x? Minus 2x upon 1 minus x square. Done. So substitute the value. So we'll say limit x tends to 1 of x minus 1 into minus, okay, this is minus 2x. So we'll say minus 2x divided by 1 minus 1 square. Or we can say this is 1 minus x, 1 plus x. Okay, this will be much more simpler and we will be able to get the term properly and say that limit x tends to 1, this is x minus 1, this is 2, correct, divided by x plus 1, 1 plus x is x plus 1 both, okay, and this is x minus 1, minus sign out, so this minus becomes plus and I wrote the plus 2 sign, correct. So if at all I cancel this 2, okay, what I get finally? I get the answer 2 divided by 2 because 1 plus 1 is 2, which is 1, which is finite. Very interesting. Okay, what I did, this is 1 minus x square, this is a plus b, a minus b, 1 minus x, 1 plus x, out of which this I wrote like that, but this I took minus sign out, become x minus 1, so this became plus, and I could cancel this easily, and 2 upon x plus 1, it is 2 by 2, it is 1, which is finite. Same way I'll do for limit x tends to 1 of x minus x0 square q of x, correct. How will I write that? Limit x tends to 1, x minus 1 square into q of x is L into L plus 1 divided by 1 minus x square. Same logic I'll use it over here also. So what will I get? Limit x tends to 1, okay, so this is x minus 1 bracket square into L into L plus 1 divided by x plus 1, x minus 1 with a minus sign because I changed the sign, okay. So 1 x minus 1 gets cancelled, correct, and what is left now? Limit x tends to 1 minus x minus 1 is left, 1 gets cancelled, L into L plus 1 divided by x plus 1, okay. So if you put a sign over here, we are going to get the value, okay, which will be finite, correct. That's the reason we are checking now. That's the reason we can say yes, x is plus 1 is a singular point because both values turned out to be finite. Now as far as the x tends to minus 1 is concerned, what we'll do? We'll say similarly limit x tends to minus 1, x minus x0 p of x will be limit x tends to minus 1, x minus 1 divided by, minus of minus 1 which is plus 1 into p of x. How much is p of x? 2x divided by 1 minus x square, or in short minus 2x upon 1 minus x square. Done. So if you simplify this, what will I get? I will get limit x tends to minus 1 is x plus 1 into 2x because I put a minus sign here, and then even this I'll adjust x plus 1, x minus 1 with the minus sign which will become plus, okay. So cancel x plus 1 and get the value which is 2x upon x minus 1. Okay? So if you substitute the value, which is 2 into minus 1 upon minus 1, which is minus 2 upon minus 2, which is 1, which is finite. Done? Simple. Now same we will try for the x minus x0 square qx. So we'll say limit x tends to minus 1 of x minus x0 square q of x will be how much? Limit, okay, x tends to minus 1, okay, x minus of minus 1, so x plus 1 square into L plus L into L plus 1 divided by x 1 minus x square. Okay, so we'll take obviously minus sign outside the bracket and write x plus 1 x minus 1. So 1x plus 1 will get cancelled, and how much will be left now? X tends to minus 1 minus x plus 1 L into L plus 1 divided by x minus 1. Okay, now substitute the value. So we will get over here what is called as minus 1 plus 1 into L plus 1 divided by minus 1 minus 1. Okay, so this will give me nothing but L into L plus 1 divided by minus 2. Okay, and here also this is minus of, okay, minus 1 minus 1, so this will give me minus 2. So 2 gets cancelled, we'll get the value L into L plus 1, which is finite. Correct? So it is here we can say that yes, x is equal to plus or minus 1 is a regular singular point, okay, for the given differential equation. That's what we have proved over here. And now the next problem, to show the irregular singular point. So here we can say next question number 6, that show that x is equal to 2 is irregular, is an irregular singular point of the differential equation. What is the equation? d2y by dx square plus x divided by x minus 2 bracket square dy by dx plus x plus 2y is equal to 0. Okay, so this gives you how much is p of x? Is x divided by x minus 2 square. And how much is q of x? X plus 2. What is the point we need to check? X is equal to 2. So what we can say? Limit x tends to 2 of p of x. How much is p of x? X by x minus 2 square. Correct? So this will be 2 upon 2 minus 2 square will be infinity. Done? As far as qx is concerned, limit x tends to 2 of x plus 2 will be 4, which is finite. Correct? So now what we need to check is as the px diverges at x is equal to 2, so x is equal to 2 is a singular point of the given differential equation. Now we need to check the similarity. It is regular singular or irregular singular. Correct? So what we'll say, limit x tends to x0, x minus x0, p of x will be limit x tends to 2, x minus x0. How much is the point? x0, which is 2. How much is p of x? Is x divided by x minus 2 square. Okay, so this will give me how much? X divided by x minus 2. Correct? So this will be 2 divided by 2 minus 2, which is 0, so gives you infinity. Done? And limit x tends to x0, x minus x0 square q of x will be limit x tends to 2, correct, x minus 2 bracket square into x plus 2, because x plus 2 is my qx. Okay, so how much this will give me? X minus 2 bracket square into x plus 2. This is 2 minus 2 and this is 2 plus 2, so 2 minus 2 will be 0, correct, so this will be 0. So what we can say, add x is equal to 2, okay, x minus 2 px diverges, okay, this is diverges and this will be 0. So therefore x is equal to 2 is the irregular singular point of the given differential equation, correct, because here you get the value to be infinity, here also we got the value infinity. So here we can say confidently, yes, this is a irregular singular point of the given differential equation. Okay, so this is the way we can solve plenty of problems if you want. There are many problems solved even in my MMP MCQ video lectures also, so go through that. Any difficulty, feel free to ask. Okay, so here I can say that as the syllabus is 100% over for the MMP paper 1. Clear? As far as exam is concerned, till now there is no notification from university, so let's wait for that. Till that, do watch all the video lectures of regular classes what I have taken, and also for the MCQs. Okay, thank you very much.